All right, guys. So today we've got some 3D printing going on, and we're starting a new project. We're going to make a bunch of parts for a satellite, but I'll let my coworker explain more of that.
So what we're building is it's called a star tracker, and it's going to go on a high altitude balloon flight. It has a camera and a baffle in the front to turn down the stray light. It points at the sky during the daytime and identifies stars, and from those images you can figure out where that camera is pointed at that particular time to very high accuracy, talking down to a couple arc seconds, which is at least 1,000th of a degree.
Okay, so these are the first parts right here. You can see we've got two of these guys, and this angle right here is different on the two parts by just like 1.5 degrees. So it's two separate programs, although they look identical here. So what we're doing is I think I've got a 3D high-speed water line cut here, just going back and forth to bring that angle in, and then drill a tap, and we're taking care of this radius since it's available right now, and then just putting a little edge break around here with a spot drill. So that's our first program. Right on. So here's where we started. We had a bar stock of this material, 1-inch square aluminum 6061, and then what we did was we cut everything to length and we ran it through the Bridgeport and just squared everything to the required size. It's a bit of an odd size, 23.81 millimeters square, and then we finished one edge. Now that will go in the CNC, and this edge, as you've seen, has a compound angle on it. Okay, so we've already cut some of these guys in the CNC. Here's the blank that we're cutting. Saw cut on this end, and that's going to end up with the angle on it. And then here are the finished parts. Well, the finished for the first operation anyways. So, just like it looked on Mastercam. It even put a little witness mark for that hole that we have to do in the future right there, if we can get that focused. So Wendell's in the back here. You can see me in the reflection there. Wendell's in the back. He's doing Aladyne on a bunch of parts that we had Send Cut Send do for us. And over here you can see, here's kind of what Send Cut Send set us. Flat stuff, and they actually have a service where they'll break, put a bend on whatever you need bent. And they couldn't bend this into a perfect box for us, but they got it as close as they could get. So now all we have to do is just complete that and rivet it together and solder it and whatever else has got to be done to build this thing up. But anyways, all the raw material for the rest of this came from Dick's Metals, and this was all machine ready blanks, so it's cut nearly to size, wrapped impeccably, and no damage, and really high quality surface finishes on everything, nothing all scratched up like everything in Hawaii seems to get. Everything's indicated by which line on the particular work order there was. And of course, just make a liar out of me, there's 3 in a row. There it is, line 7. But yeah, it's really well done. I highly recommended. That's Dick's Metals. And then back to the CNC here. What we've got. This is our setup. I've got a part stop over here. I'm just using this as a spacer. We crowd everything to the left. I've indicated the left and back as 0. And of course the top is also 0 as in my Mastercam. And then this thing just comes in with a ball and does the end, drill, tap, finish the radius, and then just a little edge break. And that's the whole program. So, program's loaded. Like I said, this is the second part, ever so slightly different. So we'll just press go. deep on the first cut. We're just doing a zigzag pattern. Comes out clean enough. Since we are cutting on the side of the ball. And then everything from here is pretty basic. Drill and tap, contour cut with a 3/8 end mill, and then a little edge break with a spot drill. Alright, so here you can see the next setup for these little brackets for this, I don't know, call it a satellite, this thing that's going to be flown up in a balloon, 135,000 feet in the air. I'm working on the back side of the part. Not my preferred method, but you know, it's pretty solid. Do we need this close a step over on all this stuff? No, but you know what? We're making nice parts. So this is a little involved. We're doing some contouring, using a flat end mill to do some contour passes, just to remove all the bulk of the material, like a 3/8. And then we're doing 3D high-speed hybrid, where it works its way down. And now you see what you got. Here's the part. What you got is this surface is angled in this direction and angled in this direction. So compound angle on that surface. So this is really the only way to cut it, like this, with the 3D high-speed hybrid strategy. And you know, as you can see, it does a pretty nice job. The only purpose of this surface is to lightweight this bracket. So everything's going to bolt from this side. Now we still have to do holes on this side and a hole on this side, which again is a compound angle. So this will be fun. All right, for the last program, we just ran a quick one just to drill and tap the other set of 2 holes. And that's kind of where we're at right there. I did stamp one of the parts because the angles are slightly different. Now what we have to do is attack this. And if you remember, that is a compound angle. Okay, so this is the setup that we're going to use for the compound angle. And on the bottom here, what I've got is a 10-inch. I could show you, but take my word for it. This is a 10-inch sign plate, and then up top I've got a 5-inch sign plate. This is very, very common. I got a vise mounted flush to the edge of the 5-inch here, and then I've just got some parallels set up here. This top one is toe clamped in, and the bottom one is clamped down to the table, and it's been indicated parallel, as you can see right there. And here's my drawing, and you can see you know, we've got one of those angles is 3.92 degrees, the other one is 5.23 degrees, and I've already done all the work for a 5-inch and a 10-inch. I don't know which one I'm going to run for which, so I just scribbled it down here. This is the size of block I have to run on the sign plate, both in inches and metric. And so the first thing I have to do is take decimal degrees and turn them into degrees, minutes, seconds. So 3.92, convert it, come up with that. And then the other calculator I like to use is Little Machine Shop. Sorry about that. There we go. littlemachineshop.com, very handy. You can enter degrees, minutes, seconds on a 10-inch 10-inch sine bar center distance and end up with a block height in inches and millimeters. And that's how we do it. Okay, we got the spacers on the big plate. We got spacers proper stack up on the little one. And just as a I wrote on the part where the 3.92 was, and then which side the 5.2 was. So just as a sanity check, on the money. So now what we do is just edge find on the back and that surface, and then we pop our hole in according to the drawing. Okay, now so because the back side of this is angled, it falls away because we did put a stack underneath this side plate tipping it up. We can't use a standard edge finder back here on this side, nor can I use one on this side. So what we're going to do is we're going to come off of this face over here for the X. For the Y, I still have to come off of this. So what I'm going to do is use this wiggler with a point on it. Spin it real slow. Yeah. Get her close. There we go. Now we can come down. We just want to touch the edge, basically. So still got some wiggle. And we just come in until I got that right on. As soon as that walks away, we're on the edge. So then what we'll do is go ahead and reset the Y to 0. Whoop, sorry. There we go. Now we'll go find our X. Okay, to find X, we can just come off of this edge, this top edge. Now that top edge is kind of the proud area, and the surface will fall away because we have tilted that vise. So, about 900 RPM, and we just ease into it until our wiggle goes away, and that guy shoots off to the side. Right there. And then what we'll do is set X, and we are, what are we in? We're in millimeters. So we need to, there it is, go to inches. And now what we'll do is move this table across. Basically what we want is we want to get 100 thou on there. Oops. And then set that at 0. And that's because our edge finder diameter here is 200 thou. So now we're directly lined up with center of that edge, and we use the wiggler to get this edge. Now we can use our drawing. Alright, so I got everything located. I got the table locked down, and you can see we're going, as this thing cut, the ball end mill made a little witness mark, a little dimple where the hole should be. And we're right on it, both in the X and in the Y. It looks really great. So what we'll do is go ahead and drill this one. That's a number 7 drill for a 1/4 20. Looks pretty darn good. Now I've just got this thing sitting. I might want to go ahead and put a clamp on this vise back there. So yeah, we see that this thing's kind of, with the pressure, it's kind of moving a little bit. So what we're going to do is we'll take our camera. What we're going to do is just put a T-nut in here and toe clamp this guy down right here on top of that right there. So that'll solidify this whole thing a little bit. I think should be good. All right, you can see right back there we've got our clamp on. Now this should be a bit more stable. Give it a try. Yeah, we're good. Okay, we got our tap locked in the chuck, and we're gonna go run this power tap through here. There we go. And there will be guys that'll say, you know, yeah, you can make that on a 5-axis in one setup. And you can. But you know what? I don't have a 5-axis, so this is how we make what we make. And got 16 of these things in total to do. Go ahead and process through those with this very same setup. Here's my little spacer. It's got a finished edge on 2 sides, so a 90. So all we do is we drop the spacer in, locate the part in, and away we go. So anyways, that's the setup to do a compound angle here. That's how I do it. Okay guys, there you go. That's a complex little part. You know, it's got 2 surfaces with compound angles, a hole on a compound angle, 3 setups in the CNC, and 1 in the Bridgeport. So I hope everybody finds that useful. Yeah, it's a cool little part, fun thing to make. And again, this is going up in some weather balloon or some balloon at 135,000 feet on a satellite kind of thing. I'm just making the parts. We'll go ahead and process through a whole bunch of flat work now. I don't know if I'll show that. Maybe we'll just look at it when it's all done. Never know. Anyway, 3D printer still kicking. Perfect, works perfect. Got my humidity down to about 16%. Out here it is 54%, so quite a drop in humidity. I think that's just fine. Flawless. Everything I print is flawless. So, okay, while the 3D printer is off to my right here, working away, we've got my computer view. The Bambu is crushing it. You can see it's doing a whole bunch of support work around some corrugated looking structure, and that's a scale model of our observatory, and we're using that for conceptual design work. This right here is what we're printing. Really a pretty cool deal. Okay, right here, so this is what we're making. This is about 9 inches in diameter. This is the concrete pier of our telescope. And then what we're doing is we're going to do a remodel project where all this is new. So we're going to use this for conceptual work. I'm going to bond all these sections together. Of course, they were printed in sections because it won't do one shot. And here you can see the detail. Stairs, there's beams, there's all kinds of stuff in there. And there's enough detail in there. That's all we need basically for this conceptual work. That'll all get bonded together. The last section's in the printer now. So all I can say is that the Bambu absolutely rocks. Just send the print and it's almost guaranteed it's going to work. I haven't had a failure yet. So that's what we're printing so far. Anyway, I guess let me know if in the comments if you want to see more 3D printing stuff, if you want to see more of what we've always been doing here, which is the machining end of things. Anything in particular you want to see made or tools tested, or you just let me know, and we'll try to put good content out there for everybody. So anyways, like, share, comment, and there'll be more stuff coming.